Good morning, my YouTube viewers. It's Crystal here. I wanted to make a video this morning, and I want to make the video on R's sample function because that's going to be a function that you're going to need to be familiar with if you want to work with probability. So the R programming language has a built-in tool for randomly selecting elements with or without replacement, and that is the sample function. This function is one of the most flexible and important tools for simulation, bootstrapping, permutation tests, and creating randomness. So when you sample, you can sample with or without replacement. If it's sampling with replacement, then basically what it is that you take a sample out, and then you put the sample for use in your studies, and then you put the sample back in. Now, sampling without replacement is you take the sample, but then you don't replace it. So that's how it works. So the first thing we're going to do is we're going to show you how to use the sample function without replacement. So sample brackets 1 to 10, comma, size equals 7, comma, replace equals false. So, and then it samples it 7 times, and it doesn't replace it. But what we can do is just to show you how to do it. We can do a sample with replacement. And the default for sampling is without replacement. That's your default. So if you don't put the replace equals false, then it will automatically default to sampling without replacement. But I just put the replace equals false and the replace equals true in there just so you can understand the syntax. But we'll run it again with replacement equals false and replacement equals true, so you can see how the sampling works. It's going to take just a little bit for it to for the program to work. Okay, so you can see this sampling is false, then all of the numbers are different when sampling is false. But when sampling is true, you notice that replacement is true. You notice that you've got 2 7s and 2 1s. And the reason why is when it takes a sample, it'll take the sample that you're going to use for your purposes, and then it will put the sample back into the list of numbers. So that's why when replacement equals false, all of the numbers are different because it's sampling without replacement. And when replacement is true, you can have duplicate or triplicate or quadruplicate numbers because after it takes a sample, it puts the number back in. And that's the difference between sampling with replacement and sampling without replacement. And this is the easiest way to use your sample function. So now we're going to do weighted sampling. And with weighted sampling, you can bias a selection against certain values. So sample brackets C, and C's, you are creating a vector, and you're creating a vector with ABC. And then comma, size equals 10, so that is the size of the sample. Replace equals true, so you're going to have sampling with replacement. And then you have probability equals C, brackets 0.7, 0.2, 0.1. And so basically what you're doing is you're creating a vector with the probabilities. So probability A is going to be 0.7. The probability for A is going to be 0.7. The probability for B is going to be 0.2. And the probability for C is going to be 0.1. So you'll notice when we sample it, you've got lots of B's and lots of A's, and you have more A's than you do B's. And the reason why that is because A has a higher probability than B, and we don't have any C's at all. Now, if we had like maybe a sample size of, let's try to change this to a 20. Let's change this to a 20. So your sample size is going to be 20. And then so you can see when you change your sample size to 20, we do actually have one C in there. And the reason, and you need to have a larger sample size because there's only a probability of 10% that you're going to get a C. You can also have sampling when X is a single integer. And so, and this is an easy way to do it. You can just sample brackets 10. And so that's going to be a sample size of 10. But basically, because in the sample, replace equals false is the default. So you don't have to say replace equals false. But I went ahead and put replace equals false in there so you'll understand how it works. And your sample is from 1 to 10, and your sample size is going to be 10. And so if you count the number, then you're going to have 10 numbers. But so just to try this out, we run it. And so you can see that you still get 10 numbers, but you get different numbers because it's two different samples. But what I wanted to do was this here. I wanted you to see what the code actually is. But it's the sample size of 10 and replace equals false. That's your default. So you can also use sample to split data. And the thing about splitting data is it's more obvious when you're working with Python's sklearn, because Python's sklearn library gives you a train test split function, and that train test split function will actually split your data between training sets and testing sets or validation sets. But R doesn't have a train test split function. So you have to split the data a different way in R. So we're going to set our seed. And what happens when you set your seed is every time you run the cell, the values are going to initialize the same. So you're going to say set.seed brackets 1, 2, 3. And then we're going to create a vector. So vector equals data.frame brackets numbers equals 1 to 100. So you're going to create a vector. Really, it's a data frame, but I said V. You're going to create a vector, which is a data frame, a single column data frame of numbers 1 to 100. So you're going to set your index. Index equals sample brackets 1 to in row V. So that's 1 to the number of rows of your vector. Comma, size equals 0.7. So that's 70% times in row V. So the size is going to be 70% of the number of rows in the vector. And since we have 100 rows, that means your size is going to be 70. So your train becomes V brackets index comma or square brackets index comma. So that means your train is going to be 1 to 70. And then your test becomes V square brackets neg index comma. And so that means your test is going to be 71 to 100. And then we check the structure of train. See if I can get this. The structure of train and the structure of test. So you can see the structure of train is 1 to 70, and the structure of test equals 1 to 30. So that means your training set has 70 elements in it, and your testing frame testing set has 30 elements in it. But if we're just wanting to do, I can say this. So what you could do, so you're sampling this, and so every time that you sample it, it's going to be a different figure. But you could do what you can say index and just say index. See, hope I'm doing this right. I'm just making it up as I go along. And then you can say so you can say, and I'm just making this up because I just want you to see how the actual indexing works. So I've never done this before. I'm doing this just on the video right now because I want you to see how the actual indexing works. So index becomes C brackets 1 to in row V. Times 0.7, see what we've got. So index equals C, 1 to in row V times 0.7 times 0.7. So it should be 1 to in row V, that's 100 times 0.7. So that's times 70%. So it says 1, 2, 2, 3, 4, 4, 5, 6, 7. So that's not really right. That's, let's see what we can do with this. Try that again. So the structure of test is okay because it's 1 to 30 and it goes all the way from 71 to 100 or 99. But the structure for train, there seems to be a problem with train. So we'll say 1 to in row B times 7. I'm going to try this. No. B. Because it shouldn't be 1 to 99. I mean, I could say this. And then it would work. But that's not really what I want to do. So there, we got it to work now. So that's the parentheses or brackets make a world of difference. So when you have index underscore becomes 1 to n row v times 0.7, and that you have to put it in brackets. And then train becomes v index underscore, and test becomes v index, well, negative index underscore. So that gives you 1 to 70 and then 1 to 30. And so that you can see that the 1 to 70 is actually 1 to 70, and then 1 to 30 is 71 to 100, which is what you want to see. And then now we're going to sample it. And then so when you sample it, you take a sample of it, and then your train and your test are going to be different. And so you can see that in the second part of it, it's sampled, whereas the first part of it, it isn't sampled. So that's just something that I wanted to show you. And I didn't plan to do it, but I just thought, well, I want to create a distinction between sampled data and unsampled data. So you can see that the unsampled data is just straight 1 to 100, with the test being 1 to 70 and the train being 71 to 100. But the sample data still has 1 to 70 elements, but each element is different in the train and the test. And so that concludes this video. The next video is going to be another subject on sampling and probability and distributions. So I hope that you decide to watch it.